Dear students, Assalamu alaikum. In this video, we will learn the second equation of motion and how can we derive the relation for the second equation of motion. We know the second derivation or relation for the second equation of motion is that displacement covered by the body during the constant acceleration is equal to the S is equal to VIT plus 1 upon 2 AT square. VIT plus 1 upon 2 ATU square. This is a relation for the second equation of motion. We have to prove this equation S is equal to VIT plus 1 upon 2 ATU square. Okay, let's come to prove it. If a body is moving, let's suppose if a body is moving with the initial velocity Vi and it is moving with a uniform acceleration for interval of time, for a period of time t means, and it covers the displacement S, moving with the initial velocity Vi and undergoing the uniform acceleration is constant for a time period of t, for interval of time t, and it covers the displacement during this acceleration is S, and that's why it attains the final velocity Vf. So these are the factors to drive the second equation of motion. Initial velocity, acceleration, time period, displacement covered, and final velocity. So these are the factors to drive the second equation of motion. So let's come and try to prove it. S is equal to Vi t plus 1 upon 2 ATU square. As we know, the body is moving with the initial velocity and acquires the final velocity, means the velocity increases or decreases with the constant rate. The acceleration of the body is uniform, means acceleration is uniform. The velocity is constant, velocity is moving is with the constant rate, means velocity increases or decreases with a constant rate. So we can take the average velocity. We can take the average velocity as average velocity is equal to Vi plus Vf upon 2. So we can take the average velocity because the body is moving with Vi and acquires the velocity Vf during the time interval t. Acceleration is constant, so we can take the mean of the velocities, means initial and final to Vi plus Vf upon 2. So, and we know the distance covered during the constant acceleration, distance covered is equal to the average velocity multiplied by time, Vav into t. T is the time interval during the constant acceleration. So the distance covered is denoted by S. S is equal to Vav. We have given the Vav average velocity is equal to Vi plus Vf upon 2. So we put the value of Vav in this formula. Vi plus Vf upon 2 into t. T is the time interval, and hence we know the Vf is the final velocity and its relation is given in the first equation of motion. So from the first equation of motion, Vf is equal to Vi plus At. We have to put this value in this equation. Here Vf is given Vi plus At, so put this value of Vf in this equation. For example, this is equation number A, this is equation number B. So it's your choice. Put the value of Vf or equation number B in equation number A. So when we put when we will put the equation number a, b into the equation number a, we will get Vi plus, here the Vf is equal to the Vi plus At, means Vi plus At upon 2 divided by 2 into t into remaining in t. Here we have substitute value and we will solve it. Vi plus Vi is equal to 2Vi plus here we know that the Vf is equal to Vi plus At and 2Vi plus At upon 2. Vi plus Vi is equal to 2Vi plus At same divided by 2 into t same. We can solve it as the 2 is given to both of these values, both of numerators. 2 is divided by both of numerators. We can give it by separately. We can give it as 2Vi divided by 2, and this is a multiplied value, 2Vi upon 2 plus At upon 2, and both of these are multiplied by the t. S is equal to 2 is cancelled by the 2, 2 cancel, remaining Vi plus At upon 2 into multiplied by t. So 2 cancel, remaining Vi plus At upon 2 into t. Vi plus At upon 2 into t. T is multiplied by both of these factors. Vi multiplied by t. S is equal to Vi multiplied by t is equal to Vi t plus At upon 2 multiplied by t square, means At square upon 2. So we can write it as S is equal to Vit plus separately 1 upon 2 remaining At square. S is equal to Vit plus 1 upon 2 At square. So we have proved this equation. S is equal to Vit plus 1 upon 2 At square. Here we have proved the second equation of motion. S is equal to Vit plus 1 upon 2 At square. So this is the second equation, means S is equal to Vit plus 1 upon 2 At square. This is a second equation of motion. Second equation motion. This is the derivation of second equation of motion. This is relation for the second equation of motion. So in second equation of motion, we derive the relation for the displacement covering during the constant acceleration of the body when the rate of velocity or increment or decrement of the velocity is constant, means the velocity is changing with a constant rate. Acceleration remains constant. Thank you.